Hey YouTube, welcome back. Have you ever wondered why systems fail completely when one small part goes down? That's what we can call a single point of failure, or SPOF. And it's something every engineer and designer must understand and address. It's a pretty important in your system design interview to understand what is a single point of failure, how to detect a single point of failure, and we will talk about popular solutions for fixing or to avoid any single point of failure. But we will do this in multiple videos, not this one. This one we will only understand what is a single point of failure. So first let's try to answer the question of the what. In a simple term, a single point of failure is any part of a system that, if it fails, will cause the entire system to stop functioning. It's like having one bridge that connects two cities. If one bridge collapses, there is no other way across at all. So, a key characteristics of a single point of failure. First, a critical component. The component's failure affect the entire system. Number two, we have no backup. Like there is no redundancy to handle the failure. Number three, high risk. Single point of failures make systems vulnerable and prone to downtime. Let's take an example to understand this one. So we have this system. Can you know where is a single point of failure? There are two single point of failures, and the main one relies here. Okay, so imagine this is an e-commerce site with a single database. As you can see, we have only one database server. If the server goes down, no one can place orders, view products, or log in. The entire system basically halts and the entire system will break down. If a data center relies on a single power source, for example, like a blackout can bring everything to a standstill. Like now think about a corrupt office that relies on one route for internet access. If that router fails, the whole office, a corporate office, not a corrupt, sorry, a corporate office. If the router fails, the whole office loses connectivity. So a single point of failure is something that when it falls, or something that when it has any problem, the entire system will stop functioning at all. So in our system, we have two single point of failure. We have our one load balancer server, and we have one database server. So that if the database server went down, we have no data, we cannot make any orders. If this load balancer server went down, we cannot, basically the client cannot send any request, and if the client sends the request, there is no actually server or no load balancer to distribute all the incoming requests across the servers. So the request will never access our web servers. So our system will stop functioning. So this is two single point of failures in our system, and we will talk about how to fix them. But let's try to answer the question, which is why it is that important. Like single point of failures can have several consequences, including like downtime, like entire service can go offline, resulting in lost revenue and frustrated users. A reputation damage, because repeated outages can harm companies' credibility. Also, there is costly recovery, because fixing a single point of failure can take time and resources, especially during peak hours. Okay, how could we detect a single point of failure, or how could we identify a single point of failure? There is three things you can think about. Okay, let's make this quite tall. The first thing is to map the architecture. Okay, you need to map the architecture, like create a visual diagram of your system components and connections, so you understand how your system works. It's pretty important. Number two, simulate the failures. Like ask what happened if this component fails. Will the system continue to work? If the answer is no, we have a single point of failure. Number 3, prioritize the risks. Like identify which single point of failure pose the most critical risks based on their impact. Okay, there are a lot of different strategies to eliminate a single point of failure. Let me do them one by one and do them with numbers. The first one is redundancy. Like you can add the backup components like a database cluster or multiple web servers to ensure the system continues working even if one fails. Number 2, load balancing. So we, instead of using one server, we're using multiple servers, and we use a load balancer to distribute workloads across multiple resources, so we don't have any resource will be a bottleneck or something like that. Number 3, failover systems. Okay, set up a failover mechanisms where a secondary system takes over immediately when the primary one fails. We can do this with the load balancing. We can just have like another system, like whenever the server goes offline, the other system will handle this. Number 4, we have a geo redundancy. Geo redundancy like distribute your infrastructure across multiple locations to handle regional outages. And lastly, we have monitoring and alerts. Like use monitoring tools to detect and respond to failures quite quickly. For example, like Netflix uses chaos engineering to identify and fix single point of failures. They like intentionally simulate failures to ensure their system remains resilient. Cloud providers as well, like AWS and Azure, offer multi-regional deployment option. So even if one data center goes offline, your applications remain available. Okay, let's try to answer another question. But I guess this question needs to be in its own video. But when the single point of failure is acceptable. So, not all systems require 100% redundancy. For example, internal tools or non-critical systems can tolerate some downtime. The decision to address a single point of failure should align with your system's important and budget constraints. And I will create another video that talks specifically when a single point of failure is not something that we should be worried about. Okay, so to wrap it up, single point of failures are components that can bring down an entire system if they fall. They pose risks like downtime, lost revenue, and reputation damage. Strategies like redundancy, failover systems, and load balancing can mitigate the single point of failures. So, remember, designing resilient systems start with identifying your single point of failures and proactively addressing them. Thanks for watching this video, and if you found this video helpful, like it and subscribe and hit the notification bell so you never miss any video, and see you guys in future videos.